So here I want to talk to you about how to divide polynomials. Right, it's the second to last operation we need to talk about. We've done addition, we've done subtraction, both super easy. Done multiplication, we're doing dividing right now, and then we're going to finish with factoring and how to solve them or write them in factored form. So right now we're talking about dividing. We have two ways to divide, long division and synthetic division. I want you to be thinking about what are the similarities and what are the differences between long division and synthetic division. When can they both be used? What's the same, what's different about that? How do we set up the problem? What's the same, what's different? And what are the steps in the process? What's the same, what's different? Because actually there's some great similarities there that we can kind of look at. First, let's talk about long division. Now, long division, we set up a problem like this, right? We have our dividend in this area. We have our divisor, our quotient, and our remainder. Now, this is a process, and we can use this for division with any polynomial. Okay, division with any polynomials. The divisor can have any degree we want, right? Here's what we're doing here. The dividend is the polynomial being divided. So we're going to put that under here. The divisor is the polynomial we are dividing by, and that goes on the left side. The quotient is our answer. And then the remainder left at the bottom will be written as the numerator in a fraction, and the divisor will be the denominator. That sounds funny. I want to show you an easy example of that. Think about 7 divided by 4. 7 divided by 4 is 1, remainder 3. And we write this. We don't write our answer as 1, remainder 3. We write it as 1 3/4. The remainder is the numerator, 3 is the numerator. The divisor, what we're dividing by, 4, is the denominator. So that 3/4 is remainder over divisor. Then, of course, 1 is part of the answer, part of the quotient. Okay, let's look at this actually with polynomials. 4x squared plus 3x squared plus 10 divided by x minus 2. We want to write the dividend, the polynomial, being divided. We are dividing this polynomial by this polynomial in standard form with 0 as the coefficient for any terms that are missing. So we have to slip in a 0x because there's no x term here, right? And then, of course, we rearrange that x to the third and x squared so it's in standard form, counting down in the degrees. Then set up the problem just like regular long division, just like we just looked at. 3x to the third plus 4x squared plus 0x plus 10 is under that division symbol, and then x minus 2 is on the outside. Now, here's the process of actually dividing. I want to walk you through this. The first term in the solution is 3x squared because x times 3x squared equals the 3x to the third in the dividend right there. Then we draw the line, change the sign of both things there, and then we go to the next row. The next term is 10x, because x times 10x equals the 10x squared that we're looking for. Draw the line, change the sign. The final term is 20, because 20 times x is the 20x that we want in this row. In this problem, we have a remainder of 50, and we'll put this in the fraction for our final answer. Our final answer here is 3x squared plus 10x plus 20 plus 50 over x minus 2, that remainder in the fraction, 50 over the x minus 2. So that is our answer when we divide. Okay. Now, with this example, there's lots of different steps, but notice we're always looking at that first term of each level. What times x is going to give me a 3x to the third? What times x is going to give me a 10x squared? What times x is going to give me a 20x? And so what we're doing then, notice that minus 20x right here, that comes from that 10x times that negative 2. So we got to still think about the distributive property to get this next level down. We will definitely walk through this in class. This is a tricky, tricky process. However, take this example, hopefully you wrote this down, and I want you to try this one. We'll check this one tomorrow in class. Come with it finished so we can look at it together. It's actually going to be the first one on your worksheet. Okay, so give it a try, do your best, and let's see what we can make happen together in class. Now, the second form of division is called synthetic division. Synthetic, of course, means a word that's kind of fake. So this is like fake division. And unfortunately, with synthetic division, it can only be used by division of a linear binomial. So degree 1, 2 terms, with a leading coefficient of 1. A great example would be x minus 3. That would be a linear binomial with a leading coefficient of 1. And it uses only the coefficients of the dividend and then the opposite of the constant term of the divisor. Okay, so we're going to look at this because this is kind of strange. The opposite of the constant in the divisor, and I'm going to call that a from here on out, goes in this little corner. So in the problem we're looking at right now, it's a negative 3 and x minus 3. We see that minus 3 right there. That means a plus 3 is going to go in this top corner. The coefficients of the dividend, including using 0 for anything that's missing, go straight across the top. And the coefficients of the quotient, it's almost like a tongue twister, go across the bottom as we saw. Okay, I'm going to walk you through the process. Synthetic division is so sweet. I love it. And I think you will too. The problem is it's only useful in certain cases, but I still think you're going to love it. Here's an example. X to the fourth minus 2x to the third plus 3x plus 1 divided by x minus 3. Set up the problem. Put the opposite of the divisor's constant term. So here we have a negative 3. The opposite would be positive 3 in the corner. Write the coefficients of the dividend across the top. So I have a 1, a negative 2. I'm going to sneak in a 0, a 3, and then a 1. It should look like this. 3 in the corner, because the opposite of negative 3 would be positive 3. 1, negative 2, sneak in that 0, 3, 1. It's just a little countdown right across. If it's not in standard form, it's got to be put in standard form, right? Counting down on those degrees. Then you add along the downs and multiply to fill the check marks. Okay, so we're going to start with that first 1 right here. We're going to add along the downs. 1 plus there's nothing here gives us a 1. So add going down. Pretend there's a 0 here. 1 plus 0 is 1. Then we multiply to fill check marks. There's a check mark. So down, up. 3 times 1 here fills this check mark to get us the next spot. 3 times 1 is 3. Add along the downs, negative 2 plus 3, adding the downs, multiplying the check mark. So adding the downs gives us a 1. Then make that check mark, 3 times 1, well that's 3 again. Multiply to make that spot. Add along the downs, 0 plus 3 is 3. Multiply to fill the check mark. 3 times 3 is 9. Add along the downs, 3 plus 9 is 12. Multiply to fill the check mark. 3 times 12 is 36. Add along the downs, and then that final 37 is actually going to act as our remainder. So we have a bunch of numbers here, and these are going to help us write the answer. Okay? The finished quotient is the row of numbers at the bottom, and we always draw a box around the remainder to kind of set it aside. So that 1, 1, 3, 12 that we saw, that's going to actually write the quotient for us. That 37 is going to act as our remainder. The degree of our solution, so I said these are the coefficients of the quotient of the solution, will always be 1 less. So if you think back, we started with x to the third. And so our answer is going to start, we started with x to the fourth, my bad. We started with x to the fourth, and so our answer is going to start with x to the third. The solution here is 1 x to the third plus 1 x squared plus 3x plus 12 plus that good old remainder written as a fraction. I love it. 37 over x minus 3, because that's what we were dividing by. Now, an interesting fact, and I know anytime I say it's interesting, you guys are like, Miss Fisto, you're dumb. But in all seriousness, I think this is awesome. The function evaluated that a, whatever number is in the box in the corner, this case is 3, is equal to the remainder, in this case 37. So if I take and evaluate my starting function at 3, my answer will be 37. We can use synthetic division to evaluate a function at a given polynomial. This is called synthetic substitution. Okay? Synthetic substitution is using synthetic division to find out the answer. Now, your turn. Okay? I want you to try this one. Set it up. I'll give you some hints. Positive 6 should go in the corner. Coefficients across the top should be 1, minus 3, minus 18. If you do this one right, and I'm sure you will because you're going to add along the downs, multiply the check marks, you should get a remainder of 0. If you do this one right, you should get a remainder of 0. Okay? We'll check this one tomorrow in class. Come with it finished so we can look at it together. I want you to try it so that you can come to class with kind of an idea, and then you know what kind of questions you need to ask. So at least come with it, try it. Division, long division, tough. Very tough. Synthetic division, really kind of easier to get the hang of. but you're going to master both. I know you will. Try both of these problems that I gave you. Look at how I walked through my examples. We'll definitely talk more in class. I know you can do this.